All right. So have y'all got those questions answered yet? Yes. We'll probably do notes and practice.
Okay, because I'm not gonna be in like any of my classes.
Notes or the practice will probably be on Delta Math,
Wait, what?
and then the notes will be on Schoology. Yes.
What's the World Cup? I'm not a soccer fan.
It's like
It's soccer.
the World Championship of soccer.
Okay.
Think the Super Bowl of soccer.
You just rage baiting.
I've never watched it. Yo, I never even played it.
You know my coaches have
All right.
Stop rage baiting.
So let's go ahead and look at these. Okay. So today we're going to be looking at identifying relations as functions, if they're, if it is. Determining whether or not they're functions, checking to see our inputs and outputs, all of that fun stuff. So the first thing that we're looking at is this FIFA World Cup problem, okay? So it is an international soccer tournament played every 4 years. The table below gives data about the year in which the tournament was held, the country who hosted the tournament, the winner of the tournament, and the total number of goals scored in the tournament. So the first question it gives us is who won the World Cup in 2006? Italy. Now, how many goals were scored in that tournament? All right. So now, when Argentina won the World Cup, how many goals were scored?
That was 147 in 2006.
Oh, Argentina won 2 separate times, right?
Yeah, but that
So what was the first time Argentina won?
That was one.
Okay. Or what was the second time they won? Won what? 132. It could be either. Based off that question, is there any way for me to know which one they're talking about? No. There's no way for me to know based off that question. I just answered both. All right. So, does knowing the year the tournament was held determine who won the tournament?
No.
If I ask who won in 2010, could you tell me?
No. Well, unless you.
Yeah? If I ask you who won in 1954, could you tell me? If I asked who won in 1982, could you tell me? So, does knowing the year let us know who won? Yes.
With the other Italy thing for the first question, it's 147 in
No, but it says.
When Italy won.
Yeah, in 2006. In 2006.
Oh!
They won with 147. Yeah. That's what I said.
Well, then why did y'all tell me the wrong one?
Well, Christina did. Christina tried
It's all my fault.
Oh, okay.
Yeah.
All right. Thank you for the catch. All right. So does knowing the year the tournament held tell you who won? Yes. Okay. Because can 3 people win the FIFA World Cup?
No.
Only one team can win. Okay. So yes, because only one team can win. Or because each year has one winner. Yes, but each individual year. Like, each year it's hosted. Not like every year. Each year it's hosted. Because each year has one winner. All right? Now, does knowing who won the tournament determine the number of goals in the tournament? No. Why? Well,
It can change.
teams can win multiple times. If I said when Brazil won, how many goals were scored? How many different times did Brazil win? 5 times, right? So would there be any way for you to know which time I was talking about? No. Okay, it's not unique. Okay, so we're gonna say no because teams can win more than once. If your answer is not the exact same as mine, it's okay as long as it's in the same idea. Yeah. No, because teams can win more than once. All right, now, Does knowing the host country determine the year in which the country or the tournament was played? If I say, what year did Germany host? How many possible answers are there? Germany hosted 2 times. Is there any way for me to know which one I'm talking about? No, not unless I get a lot more specific, right? So, does knowing the host country determine the year? No, because teams can host more than once. So the reason we looked at this is some of these relationships, okay, they're all relations. They're all related. It's relationships between different things. But some of them represent functions. And that is what this unit is all about, is functions. So first things first is we are going to identify what is a relation and what is a function. So relations. Relations are just a set of ordered pairs, okay? It can be anything that's related. So all of those relationships we talked about, the year the cup was hosted and the winner, that's a relation. The winner who won determining the score, that's a relation. It may not be a function, but it is a relation. A function is a relation, okay, is a relation where each set of inputs are going to be our x, has exactly one output. Which is our y. And basically that means you have no repeated inputs. So in the case of our FIFA World Cup example, will there ever be any repeated years? Are they ever going to hold 2 World Cups in a single year? No, that's not going to happen. There's no repeated inputs. But can the same team win multiple years? Yes. So you can have no repeated inputs, but repeated outputs are okay. So another way we can think about this is with birthdays. So Trinity, how many birthdays do you have? 1. Will you ever have more than 1 birthday? When is your birthday? November 12th, okay? Does anybody else in here have a November birthday? Okay. So if I was to say Trinity's birthday is November 12th. Jordan's birthday is November? Jaden. November 18th. Okay? So those are functions, right? Can there ever be another answer to either one of those? That's a function. What if I said November is Jaden's birthday? What could also be the answer to that question? November is Trinity's birthday. So when it gets flipped and there can be multiple, like, do you see how each of the, let me rephrase that. So the same input to be a function can only have one output. So would me making the input November and my output being birthdays be a function? No, because both of them have a November birthday, right? It wouldn't be unique. But what if I made the person having a unique birthday? Would that be a function? If I said Trinity's birthday is, how many birthdays does Trinity have? How many birthdays does Jaden have? One. There's only ever one answer. But if I said November is Jaden's birthday, is that the only answer I could have there? No, I could have multiple answers. November is a lot of people's birthday, right? So would that be a function? No. Okay, so that's what it means. So we're going to look at examples of this using ordered pairs because it's really easy to see in an ordered pair when it's a function or when it's not a function. So for function, we're going to use the example. We're going to use a squiggly bracket or a brace. So we're going to do 0, 6, 5, -2, 7, 9, and 11, -1. And then we're going to close the set because we're looking at a set of points. When we use the squiggly brackets or the braces, those are meaning we're talking about a set. It's just a set of numbers, a set of points, a set of something. Okay? A set of giraffes. It doesn't matter. It's just a set. So here, the reason this is a function, if I look at my inputs, if I look at my x, are those all unique? Are all of my x values unique? Yeah, they are. They have no repeated x values. So because of that, that is a function. That's what makes it a function. No repeated inputs, okay? No repeated inputs. Now we're going to look at a not a function example. Okay, so let's do the set of the points -4, 2, 1, -5, 1, 7, and 5, 6. Why would this not be a function? Because there is an input repeated. That is what makes it not a function. So we're going to look at some of these examples of relations and determine whether or not they're a function or not a function based off of their inputs. That's what we're looking at. And if it helps you to the side here, you can put x, y, which is your input, output. So for number 1, repeated outputs are okay, but we're looking for inputs. Is any repeated inputs? No. So if there's no repeated inputs, is that a function or not a function? It is a function. Because all of our inputs are unique. All of them are unique, so we are good. No repeated. Okay, then we're going to look at question 2. So question 2, do we have any repeated inputs? There are 2 2s. So is that a function or not a function? So we're going to put not a function. All right, now we're going to look at question 3. So both of those are sets of ordered pairs. Okay, now we're going to look at sets of tables. These are tables. So for 3, is 3 a function? Why not? There are 2 3s. That makes it not a function. All right, for number 4, are there any repeated inputs? So that means it is a All right, now we're gonna look at a mapping. These are mapping because each input is mapped to an output. That's why they are named mappings. Okay, so for number 5, it is a function. Each input is mapped to exactly one output. Okay, for number 6, is number 6 a function? Why not? Because negative 1 has 2 outputs, so that doesn't work. So negative 1 has 2 outputs. So x is your input, y is your output. And here, we have an x that has 2 outputs, so that is not a function. That is like our example where November has 2 birthdays, okay? Whereas this here is like one person has 1 birthday. That's the difference there. All right. Now, we're going to look at how to determine if they are functions from a graph, okay? So when given a graph of a function, this specifically only relates to a graph.
That's so scary.
For a split second, my heart stopped. That was, yeah.
Who's that?
I have no idea who was in that. But yeah, for a split second, I was like, what was that? And then it was just, you know, it's okay.
Can I go challenge him to a battle?
No.
Can I stop eating me?
Like,
My family.
in his honor. No?
Can I go eat a bath?
That banana can't split.
Oh.
Oh.
All right. So, when given a graph, you use the vertical line test to determine whether the relation is a function. So, the vertical line test states, okay, if a vertical line intersects a graph more than once, then it is not a function. So let's think about why that is. What is the equation of a vertical line? Is it x equals or y equals? X equals. So if that vertical line intersects it more than twice, that means x has 2 places where it equals that. That means we have more than one input. So it can't be a function. That's where that comes from. So on each of these, we're going to draw. First, we're going to draw a coordinate plane. So do a quick little sketch of a coordinate plane. And do that for both of them. And then on the coordinate plane, we are going to draw a graph. Okay, when we are referring to a graph, we are referring to what is drawn on that coordinate plane. Okay, so first one, let's do something like this. Then for the second one, we're going to do something similar, just flipped sideways. Okay, so when we look at a function, when we look at something that is drawn like that, and we use a vertical line, I'm going to get a color that will show up more distinctly. And I draw a vertical line on that. How many times does that line I drew intersect the graph? One. One time, right there. Okay? So that makes it a function. Whereas over here, how many times does that line intersect the graph? Twice. So that makes it not a function. That means there are two inputs or x values there's two of the same x values. All right, so we're going to use the vertical line test on some of these examples. So we're going to draw a vertical line. Okay, so if I draw a vertical line, how many times does it intersect that graph? Twice. So that makes it not a function. It's if any point on the graph it intersects more than one, it's not a function. Because if I was to draw this line here, how many times does it intersect right there? One. But here it intersects twice. So if it ever intersects more than once, it is not a function. All right, for number 8, it is a function. Because it does not matter where I draw that vertical line. It will pass the vertical line test, so it is a function. All right, for number 9, it is a function. Because it does not matter, it will always intersect one time. Okay, for number 10, how many times does a vertical line intersect this graph? Twice, so it makes it not a function. All right, do 11 and 12 for me real quick. Well, good. So just sit there quietly for just a second.
11.
So, is question 11 a function or not a function? Why is it not a function? It fails the vertical line test. For 12, no, we're not done. For 12, is that a function or not a function? It is a function. It passes the vertical line test. All right. So if you disagree, where does it fail at then?
I think he's just saying it because he wants to say something.
I think so too. All right. Also, I want y'all to do 13 and 14. Go ahead and do 13 and 14 for me. All right, for 13, it gives us a vertical line. If I draw a vertical line on top of that vertical line, how many times does it intersect? The entire thing intersects, right? So is that a function? That is not a function. Because it will fail the vertical line test because it is the vertical line. It intersects infinitely many times. Okay, for 14, does 14 pass the vertical line test? How many times does it intersect? Just one time. So that is a function. All right, the next thing we're going to talk about today is something that is going to be a reoccurrent thing for the rest of the year. Okay? It will also be a reoccurrent thing in Algebra 2, and it will be a reoccurrent thing in pre-cal. Being able to do domain and range is very, very important, okay? So domain. Domain is the set of all x values. Domain is your inputs. It is what you are inputting into the function. Whereas range is the set of all y values. It is your output. It's what you're getting out of the function. So what we're going to do for 15 and 16 is we are going to not only identify the domain and range, but we're going to represent the relation as a table, a mapping, and a graph. Okay, we're going to set it up as all three. So first, it gives us a set of ordered pairs. So that is what we are going to use to get everything else from. So first, just looking at that set of ordered pairs, remember, when you have an ordered pair, it is x, comma, y. So knowing that, for 15, what is the domain? We're going to write it as a set, so we need a brace or a squiggly bracket. To write the domain, what is the domain? And 1. There are 5 items in the domain. That is just our x values. That's all we need. Now for our range, what is our range?
4, -4, 1.
Oh, 4 what?
4, -4.
No, -1.
Oh, wait, -1.
Yep. Then +1.
Yeah, 4, 3.
It is just the list of all y values. Okay. Now, we are going to do x and y values in a table. So we're just going to put the points in here. So the first point is -5, 4. -4, -1, -2, 1, 0, 4, 1, 3. All right, from here, we're going to draw it as a mapping. Okay, so to do this as a mapping, we have our x values and we have our y values. Whenever you're doing a mapping, you will not write duplicate numbers. You will only write numbers one time. So is there any duplicates in our x values? So we have -5, -4, -2, 0, 1. Is there any duplicates in our y's? What? 4. So we'll just do -1, 1, 3, 4. Usually I do those in like numerical order, smallest to biggest. Then we just draw the lines to connect them. So -5 goes with 4. So we draw the line to connect. -4 goes with -1. -2 goes with
Does it matter what order
1.
it goes in?
I try to do them in numerical order just to make it easier. 0 goes with 4. And 1 goes with 3. And then for the graph, we just plot the ordered pairs. So on our graph, we will do -5, 1, 2, 3, 4, 5, 4. So that's -5, 4. We have -4, -1, -2, 1, 0, 4, 1, 3. We just plot our points. Now, does this represent a function or not a function? It is a function. Then we are going to look at the next question. All right, for the next question, question 16. We're going to start with writing our domain. We're going to do the set of all x values. What is our domain here?
-4, -3, -4.
Do I need to write -4 a second time? No. What? We should have 4 items in our domain. Okay, for range, what is the set of our y values.
-4, 0, 1, 5,
And then we just put our points in the table. So our first point is -4, -4, -3, 4, -4, 1, 2, 5, -1, -3. Then we are going to set up our mapping. So x and y. Do I have a duplicate x?
no,
What?
-4,
So we will just put -4 one time. Then we'll do -4, -3, -1, 2. Then for y, what do I need to put for my y?
1,
We'll try to do it in numerical order, so smallest to biggest.
-4, -3,
1, 4, 5. And then we're going to map them. What does -4 map to?
-4,
What else does -4 map to?
1,
What does -3 go to? What does -1 go to?
-3,
What does 2 go to? Then we'll plot those points on our graph. -4, -4, -3, 4, -4, 1, 2, 5, -1, -3. We are just using the x coordinate and the y coordinate to plot those points. Is that a function or not a function? Not a function. All right. Now we are going to look at 17, 18, and 19, and then we're going to call it a day for today. So for 17, is 17 a function, yes or no?
yes, no,
Wait, let me.
no, there's 2 -1s.
There are 2 -1s. So that makes it not a function. All right. What is the domain?
Just all the X.
Mm-hmm. And what is our range?
-1, 0, 5, 3, 7.
All right. For 18.
No,
Again, it is not a function, but why is it not a function? The 6 gets mapped to 2 different things. So that is the problem.
Wait, 6,
What is the domain?
6, 7. Oh, then 8.
All right. For the range, what is the range?
4, 3, 1, 5.
-4, 3, 1, 5. All right. For 19, is that a function?
Yes,
It is a function. Why is it a function?
it doesn't intersect.
It passes the vertical line test. It only ever intersects one time. Okay. So for domain, I look at my x values of those points. What is the x value of this point? -4. What is the x value of this point?
-2.
Mhm. And
And 2.
4. So our domain is -4, -2, 0, 2, 4. Then for range, we use our y values. What is the y value of this point? 2. What's the y value of this point? -2. What's the y value of this one? The y value. 0. The y value of this last point? 2. So this will be -2, 0, 2. All right, and that is where we're wrapping up today with functions.